Hi everyone, in this video we'll be discussing the chemistry section of 1st February Shift 2 paper. This was the last paper of the session 1 and I found this paper to be very easy. Let us see the questions. The first question of inorganic chemistry is, which of the following will have color due to DD transition? So if we talk about DD transition, it will happen only if we do not have D0 or D10. In D0 or D10, we do not have DD transitions as all electrons are paired, or I can say there is no electrons in D0. So D0 and D10 are usually colorless and they usually do not have DD transition. Let us talk about KMnO4. In KMnO4, the oxidation state of Mn is +7 and Mn is basically 3d5-4s2. It is again D0, so no DD transition. K2Cr2O7 is again, chromium is +6. Chromium is generally 3d5-4s1. So it is again D0, +6 would be D0. K2CrO4 is again +6. It is again D0. So all these three are not colored due to DD transition. They are colored, I agree, but the reason is ligand to metal charge transfer. 1, 2 and 3 are colored due to ligand to metal charge transfer. CuSO4 basically has Cu +2. We have copper is generally 3d10-4s1 and when I remove 2 electrons I'll get 3d9. So DD transition can take place here. And we know CuSO4 is blue in color. Right? So answer is 4. Next, which of the following has the highest third ionization energy? That means it is easy for us to remove the 2 electrons, but when we remove the third electron, either we are removing it from the fully filled subshell or we are fully filled shell, or we are removing it from half filled subshell. Right? So if we talk about Mn is basically the inert gas, then we have 3d5-4s2. Inert gases are gone, by the way. And if we see, it is easy for us to remove the first electron, we'll get to 4s1. It is again easy to remove the second electron. Now when I have removed 2 electrons, I have 3d5. It is half filled configuration. The subshell is half filled, so it will be difficult to remove the electron. So the ionization energy would be unusually high. And now let us see the other options as well. Vanadium is 23. So it is argon, 3d3 and 4s2. So on removing the 2 electrons, the third electron I will have to remove from 3d3. Not a big ask, right? Out of these 2 options, till now I think Mn is the best. 24, I think again not a big ask. It would be 3d5-4s1. After removing 2 electrons, I will get 3d 1, 2, 3, 4. It would be 3d4, right? And iron would be argon and 3d6-4s2. So after removing 2 electrons, we will get 3d6. So out of these, all of these options, 3d3, if we see 3d4, if we see 3d6 and 3d5, 3d5 is the best option. It will require the highest ionization energy. So the answer is 1. Next, which of the following has highest reducing power? I think I have seen this question for the 3rd or the 4th time in this session only. In the first session of JEE Mains, I have seen this question in different papers. This is the 3rd time I am seeing this question. So I have already told this. If you have watched the previous videos, you know what happens as we go down. The bond length has increased and it is easier for us to break this bond. If it is easier to break this bond, we'll get H easily. And if we are getting H easily, it can be added to the other compound or the element. And basically, addition of hydrogen is reduction. So reduction of the species, the other species which is present, can be done easily. That means BH3 is acting as a BiH3 is acting as a reducing agent. It will have the highest reducing power because it can donate H easily. Both D block and P block consist of metals and non-metals. Useless statement, D block is purely metals, right? This is incorrect. Non-metals in general have more electronegativity and more ionization energy than metals. Yeah, that is correct. They are present on the right hand side. P block elements, most of them are non-metals, and since most of them are non-metals, in the above periods they have high electronegativity and high ionization energy. So incorrect and then correct. Fourth is the correct answer. SiO2, GeO2 are acidic while Sn and Pb are amphoteric. So we know boron, this belongs to carbon family, carbon, silicon, germanium, tin and lead. Right? We know these two are amphoteric in nature. All the oxides of Sn and Pb, be it +2 or +4, right? SNO, PbO, SNO2, PbO2, all are amphoteric in nature. This statement is correct. SiO2 and GeO2 are also acidic. Yeah, that is also correct. These are basically non-metals, right? Carbon also, they are generally non-metals, and non-metals will produce acids, right? The first statement is correct. The allotrope of carbon has unique catenation property due to p-pi d-pi bonds. Carbon doesn't have d orbital, right? If it doesn't have d orbital, how can it form p-pi d-pi bonds? It can only form p-pi p-pi bonds, right? So this statement is incorrect. So first one is correct, second is incorrect. Correct statement is fourth. Carbon basically have unique catenation property, that is correct. It forms it is basically tetravalent, or it forms large number of bonds. Everything is correct, but the bond it forms is p-pi p-pi bond generally. Right? Among Mn+3 and Cr+2 is reducing agent, and Mn+2. I think the question was Mn+3 is oxidizing agent. The second statement is half-filled electronic configuration is more stable, that is correct. If we talk about chromium, chromium is basically 3d5, 4s1, and if I remove 2 electrons I will get 3d4. This is basically Cr+2. Cr+2 has a tendency to go to Cr+3 because it will get a configuration of 3d3. If I bifurcate the d orbitals into T2g and Eg, we know d4 would be something like this, and d3 will have a symmetrical distribution of electrons in the T2g subshell. So yes, this is stable. The first statement is correct because Cr+2 wants to go to Cr+3, means it wants to oxidize itself. If it is oxidizing itself, it will act as a reducing agent. So the first this part is correct. Mn+3. If we talk about Mn is basically 3d5 4s2. Mn+3 would basically be 3d4, and we would want this to go to 3d5 because d5 is basically half-filled configuration, right? So yeah, Mn+3 wants to go to Mn+2, means Mn+3 wants to reduce itself. If it is reducing itself, it will act as an oxidizing agent. So both the statements are correct, right? Actually, you should remember this. This is very important. If we talk about the oxidation state till chromium, +3 is more stable. After manganese and from manganese, +2 is more stable, right? This is very important concept. Next, in pi bonding molecular orbital, electron density is not present above and below the intermolecular axis. So if we talk about the pi bond, how is it formed? We basically have plus minus, plus and minus. This is bonding. So eventually these two will overlap, and we actually make it like this. This is pi bonding. So it is the electron density is present. It is present above as well as below. This is incorrect statement. In pi star will basically be away from each other. As the sign is opposite, they want to be far away from each other. Two nodal planes. Yes, this is one nodal plane and this is second nodal plane. First statement is incorrect, second statement is correct. the fourth option is right. Right. Next is Ni plus 2 and DMG. So finally they have asked the rosy red PPT question, which is Ni DMG whole twice. It gives 6 membered covalent chelate. Okay, let us see if we talk about DMG. So basically what happens, DMG is a didentate ligand and the lone pair donation takes place through nitrogen. So we have carbon double bond carbon and we have CH3 like this, we have CH3 like this. Similarly, nitrogen has a lone pair here, nitrogen has a lone pair here. Carbon double bond carbon, CH3 and CH3. Also what happens, we have end and OH and one of these we have O minus. It is basically DMG minus. So this is the hydrogen bonding, right? This is NiDMG whole twice, which is a rosy red PPT. Now they are saying 6 membered covalent chelate. Covalent bond, if they are talking about, then covalent bond is basically this. This is the chelate, right? Chelate ring is basically 5 membered. It is not 6 membered. This is incorrect. This, if you are talking about, this is a chelate ring which is due to hydrogen bonding, not covalent bond. Hydrogen bond, if you say, if instead of covalent chelate it would have written that hydrogen bonded chelate, I would have agreed with this. Presently I am not agreeing with this. Prussian blue is basically Fe4 FeCN6 whole thrice. So we know this is plus 3 and this is 4 minus, and inside we'll get plus 2. I hope you know the name of this molecule. This is called as ferric ferrocyanide. So yes, we have plus 2 as well as plus 3 oxidation state. Again, first one is incorrect, second is correct. Fourth is the correct answer. Right? Last question of inorganic chemistry is to determine the correct option. If we talk about CO, in every case we have CO plus 3. NH3 is a strong field ligand, so pairing will happen. F minus is a weak field ligand, so pairing will not happen. If we talk about cobalt, it is basically 27, that means 3d7 4s2. CO plus 3 means 3d6 we have. So in case of ammonia, we will have something like this, and in case of fluorine, we will have something like this. Right, so this is spin is paired, right? And this is spin is free, right? So the correct answer would be, means this is diamagnetic and this is paramagnetic, right? Next we are starting physical chemistry. So the first question is on solubility. They are asking about the KSP of Ca3PO4 whole twice. So if we talk about Ca3PO4 whole twice, it will dissociate to 3Ca plus 2 and 2 times PO4 3 minus. Now if we talk about the solubility, if it is S, this would be 3S and this would be 2S. The value of KSP would be 3S whole cube and 2S to the power 2. 3 to the power 3 is 27 into 4 is 108, S to the power 5. Right? So KSP in terms of this S, which is molar solubility, is given to us. And if we calculate S, which is molar solubility, it will be moles by volume. So what is moles? In 100 ml it is W grams. So moles would be W by the molecular mass, which is M, divided by the volume in liters. So it would be 0.1, 1 by 100. So this will be 10 W by M. So on substituting this value, KSP would be 108 into 10 to the power 5 into W by M to the power 5. Right, I think the answer is C. Simple question. I would say this is one of the easiest question they could have asked from atomic structure. I hope everyone knows the number of radial nodes in a particular orbital is n minus l minus 1. N is 3 in this case. For p, the value of nl is 1. The answer would be 1. Right? Next, they are asking delta G at 300 Kelvin if K equilibrium is equal to 10. Okay, and they're asking, and they're saying if delta G naught is basically x into 10 to the power minus 1, find the value of x. Useless question they have asked. We know delta G naught is basically minus 2.303 RT log K equilibrium, right? Log K equilibrium is basically 1. So minus 2.303 RT. R is 8.314. Temperature is 300 into 1. Since they want answer in kilojoules, I'll divide it by 1000. Right, so this value you can just calculate. This into this into this into 10 to the power minus 1 is already present. So this is approximately 25 into 2.3. You can calculate this value, right? Simple question. So they have finally asked this question. They used to ask this type of question in JEE Mains 2021 or 2020. So what is happening here? We have a hydrocarbon. On reaction with oxygen, we will get CO2 and H2O. They are saying this is 40 ml, this is 50 ml. And we have taken 10 ml of this. So you should know for gases, PV is equal to nRT, or I can say volume is directly proportional to moles. So just like volume, we can consider the moles as well. For example, I can say these are 10 moles or 10 millimoles, these are 40 millimoles or 40 moles, and these are 50 millimoles or 50 moles. So you can apply stoichiometry on the volume part as well. So we know carbon has x moles here, we will need x moles of carbon here. So from 1 mole of this, we are getting x moles of this. And from 10 moles of this, we are getting 40 moles of this. Means we are getting 4 times. Means here also we should get 4 times. So it is clear to us x is 4. Right? And if we talk about y, from 1 mole of this, I will get y by 2 moles of this. Right? Because total moles for hydrogen would be y by 2 into 2, which is y. So from 10 moles, we are getting 50 moles. So I can say it is 5 times, and here from here to here if we go, we are getting y by 2. So we basically know y by 2 is 5. If y by 2 is 5, y is 10. So the formula becomes C4H10. X and y, the sum is basically 14. And this is a good question. Next we are given with a reaction, and we are given with a value of log K. We need to determine the value of log K itself. So log K is not given, we need to determine log K. Acha, since we are at equilibrium, we know delta G is 0. We also know E is 0, and E of cell is 0. And through Nernst equation, we know E of cell is E naught of cell minus 0.059 by n log of Q, or at equilibrium I'll write it K. Now if I see the reaction, we have basically Mn from plus 7 to plus 2, the change is of 5. And if we see here, this is plus 3 to plus 4, the change is of 1 into 2, 2. We'll cross multiply the changes to balance the reaction. You know that this is 2 and this is 5. So if I calculate the number of electrons exchanged, how can I do that? You can basically take anything. Let me take K-4. The charge difference is 5 and the number of K-4 is 2. So that is 10. Or if you want to calculate through H2C2O4, the change is of 2, and then we have 5 molecules of H2C2O4. So 5 into 2 again. The number of electrons exchanged would be 10. And at anode and cathode we'll get the same number of electrons, so that is 10. So we have figured that out. We have to calculate log k, and I think log k from here would be n into E naught of cell divided by 0.059. What is E naught of cell? I think you know that, reduction potential of cathode minus reduction potential of anode. So reduction potential of cathode is basically reduction part, so reduction is K-4, so 1.51 minus, if you see this value, this is oxidation potential, +3 to +4, है ना? We would have to reverse this, so we would need minus 0.59. So the E naught of cell would be this value, 1.51 plus 0.59, this would be 2.1, I guess. Yes, so you can substitute the values. This is 10 into 2.1 divided by 0.059. Right, it is approximately 21, but you can nearby say it is 0.6. So this is approximately 6 threes, let me say 35.5 into 10 to the power or basically the answer is 35.5, something like that, and I can say this is 3.55 into 10 to the power 1. So the value of x should be 1, right? Yes. Next question is from liquid solutions. Ethylene glycol of x kg is mixed with 18.6 grams of solvent. The depression in freezing point of the solution is this. Find the value of x. So we know delta TF is IKFM. Ethylene glycol is basically CH2OH, CH2OH. You know this does not dissociate easily. I should be 1. So delta TF is basically 24. I is 1. KF is 1.86. Molality would be moles. So we have x kg, so x into 1000, and this is x into 1000. This is the mass divided by molar mass, which is 62. These are the moles divided by the mass of the solvent in liters. So this is the value. Right, I think you can calculate the value of x easily. Right, this can be done. Let's move to organic chemistry. So organic chemistry has been the easiest in this JEE Mains attempt, right? If we see C2H5OH, alcoholic KOH basically undergoes elimination. So we basically had something like this. On elimination we will have CH2CH2. Br2CCl4 is basically anti-addition of bromines through a non-classical pathway. Then we have KCN. So what will happen? I'm writing them on the same side. They could be different side as well. Actually they are on the different side, but I'm writing in this fashion. And then we know on hydrolysis cyanide gets converted to acid. So COH, COH. If you remember Ohm's gap, this is 0, 1, 2. So we have S, means this is succinic acid. Right? Compound D is succinic acid. Which of the following sets of element can be detected by Lazar's test? Through Lazar's test I can determine halogen, chlorine, bromine, iodine by making the respective sodium chloride. We basically use soda extract to convert the covalent nature into ionic nature. N also, sulfur also, phosphorus also. We basically can use Lazar's test for each and every element. That is correct. N, P, N, S, P and halogens all are correct. Meta-directing groups are those groups which basically have -M. And if you know -M, how do we determine? We should have something like this. A double bond B connected to a benzene ring or any group. A triple bond B or A positive. And we should not have something like this, a lone pair, because it is activating. So as you can see here, nitrogen is activating, this cannot be your answer. Nitrogen again is activating, this cannot be your answer. Chlorine is activating, nitrogen also can donate, this cannot be your answer. NO2 is correct, A double bond B correct, A double bond B, A double bond B, right? I hope you can see A double bond B everywhere. This is A double bond B. So very simple question. Now we have to match the column. If we talk about freons, freons are basically present in refrigerants. It is used for refrigeration. DDT is an insecticide only. I think this you study in class 9th or 10th itself. CCl4, also known as pyrene, has low melting point and it is used as a fire extinguisher. I think everything was connected in the right fashion. So it would be 1, 2, 3 and 4. Generally we use acetone as nail polish remover, CS3COCH3. It is also whitener remover. If you have used whitener, there is another bottle of acetone which comes with the whitener which can remove the whitener. So nail paint remover or whitener remover are basically acetone. Zinc dust on reaction with phenol. Zinc has only a single purpose in life, to take an electronegative element like oxygen or two halogens, right? So it takes away oxygen and it forms benzene. So A is going to be R. See, again they ask Riemann-Tiemann reaction. If you have been following these sessions, solving sessions, you will find we have seen Riemann-Tiemann reaction at least 3 to 4 times, right? This is CHO. So this is salicylaldehyde, so it should be matched with P. And next is COH. This is coal base carboxylation. So basically we will get salicylic acid. COH, concentrated nitric acid, is picric acid. I hope all of you know the structure of picric acid. It is basically 2,4,6 trinitrophenol. Right, which of the following has highest boiling point? Simple question. Whenever we have something which can do hydrogen bonding, it will have highest boiling point. There is nothing near this option. Alcohols have very high boiling point. There is no boiling point in the rest 3. And the worst would be this, because this only has a hydrophobic carbon chain. Which of the following shows negative resonance effect? So CS nitrogen we just discussed is plus M group, oxygen is plus M group. But if we talk about COH again has A double bond B. You can see here it is A double bond B. So it shows minus M, which is minus R or minus M is the same thing. COH has negative resonance effect. So next question, the first reaction is basically Lindlar's catalyst, H2PD BaSO4. This is cis addition, cis product. The addition is syn addition. If we talk about the reactant, we basically have CH3, C triple bond C, C2H5, right? The addition takes place in the syn fashion. So this is basically 1, 2. So pent 2 ine. This cannot be correct, this cannot be correct. And second is but2ine. So I hope you know Na liquid ammonia with H2 is basically Birch reduction. We get anti-product, anti-addition product, right? CH3 like this. Trans product or anti-addition product, right? So this is trans but2ene, trans but2ene. The correct answer is 3. Very simple question. So again they have asked a question on monochlorination. They have been asking a question on monochlorination every day, I can say, and out of 2 shifts you will find a question on monochlorination in 1 paper at least. So we have 2-methyl butane. This position and this position are equivalent. So let us first halogenate there itself. So let me say I have halogenated, I have added chlorination at this point. Next I will add chlorine here. Next I am adding chlorine here, and finally I am adding chlorine here. So this carbon is optically active. So there will be two forms of this. This is optically inactive, one form of this. This would be optically, this is inactive, this is active, right? So this is 2. Here no carbon is optically active, so total 6 stereoisomers, total 6 products we will get on monochlorination of 2-methyl-butane. How many compounds give precipitate with Hinsberg reagent? So I hope you know Hinsberg reagent is basically PHSO2Cl, and what happens if we have 1 degree amine? It will form a precipitate, and then precipitate can be dissolved in an alkali. If we talk about 2 degree amine, 2 degree amine can form a precipitate. It doesn't dissolve in alkali. And 3 degree amine is basically not forming precipitate. So what we get to know here is we need to look for 1 degree as well as 2 degree amines. 1 degree, 1 degree, 2 degree, 2 degree. So I think 1, 2, 3, 4. The correct answer is 4. Right, so that is all about this paper. I hope you enjoyed this complete series. We have discussed all the 10 papers of this shift.